Hey everyone, welcome back. So this is your last lecture of the whole semester. Congrats for making it this far, and I appreciate your guys' participation in the Discord and with all of your hard work in getting to know and learn R. I understand it can be a bit of a learning curve, but if you decide to lean into this stuff, it's a really valuable skill set to have moving forward. This kind of stuff is only going to be more valuable in terms of the workforce and in academia. And so I really recommend that you consider really leaning into and trying to memorize this stuff. This last lecture is going to be on presenting your work. I'm going to keep this same format of showing you information in RStudio versus in the presentation version of RStudio, right, where I'm knitting the presentation file. So you can, again, let me know if you prefer this or the lecture slides when we move on. So there are two different packages you need for today. So again, you can use Haven and all these other things if you want to knit your own work, but the big ones that you need to know right now are Tidyverse and SJPlot. So make sure you load those libraries. This one is particularly important in order to see the actual data set. And so SJPlot has this awesome function called viewDF. And when we run this, it takes the SPSS file, which has labels, and puts them into something we can look at that's really handy. So say one of the variables that we care about is DemEd, which is democratic education or demographic education. It shows you the question. So what's the highest level of school you've completed? And also gives you all of the information on the different labels. So there are 8 different labels. So when you look at the data, there's going to be all numbers 1 through 8. And each of those responses corresponds to a different label. So if somebody's cell, like a particular observation, gets a 1 for DemEducate, it means that they only got a 12th grade or below education, no high school diploma. If they got a 5 or have a 5 there, it means that they got their bachelor's degree. So it gives you all of the questions and the labels for each of the numbers. And this is going to become important when we have to kind of manipulate our variables a little bit in order to tell R that they also are not just numbers, but they're factors. So like we'll use gender in this particular one. And male is 1, 2 is female. We have to tell R that these are not just numbers, but they're factors. So they should be treated as different categories rather than numbers. But this is what's going to allow you guys to interpret those numbers as they mean something in the data set. So that comes from the viewDF function. It'll pop up here on the right-hand side, exactly what you need. So we're going to start with t-tests and ways that you can visualize that. So I'm going to give you guys a guest lecture from Professor Mario that the output usually is done best in like Google Docs or creating a table and just putting the results in a table that looks a lot prettier. And so that'll be in your guest lecture. But again, remember, it's 2 groups and 1 interval ratio. But in terms of beyond just interpreting the output, you may want to have, I will probably want you to have 1 graph and 1 table in your final project. You can do that graph as either in this case, because we have groups and an interval ratio variable, we can do histograms or box plots. So I'll give you guys this file, but if it starts with therm, so any of these variables here on the right-hand side, therm AOC, therm ASI, therm Biden, therm big B or big business, any of these, since they're interval ratio, we can use either histograms or box plots, because remember, t-tests are the differences between 2 groups according to an interval ratio. So the interval ratio we're going to investigate here is feeling thermometer towards Alexandria Ocasio-Cortez. And we're going to compare that against different partisan groups. So because therm AOC is interval ratio, we're able to create a histogram of that. Here's a histogram. It's on line 30. It's using the function hist. And we're able to see all of these different, the range of feeling thermometers. Remember, feeling thermometers go from 0 to 100. The more close to 100 you are, the warmer you are towards that candidate, person, or thing. Closer to 0 is how cold you are. So there's actually a huge spike of people that are really close to 0, between 0 and 10, right? Because histograms use bins. There's a lot of people that feel really coldly towards AOC, and there's a lot of people that feel pretty neutrally towards AOC, right? Between 40 and 50. So she's a bit of a polarizing figure, as we're able to see here. But maybe we want to, again, because we have a t-test that we're in theory wanting to do, looking at this therm AOC in terms of the different groups that we care about. So maybe we want to run a box plot, which shows the mean and the distribution of that data around the mean, right? A little bit more concretely. So we're going to use this box plot function. And that box plot function shows that dark black line. That dark black line is your average or your mean. So the average feeling thermometer score for a Democrat, somebody that got a 1 in this category, is about 50, right? So a lot more warm. Well, AOC is a Democrat, so this makes sense. But that spike at 0 was definitely the non-Democrats. So Republicans or independents were much more cold towards AOC than the Democrats. And so we have some tentative support for our hypothesis here. We also can kind of check what's happening in the box plot with this summary function again, right? The summary function is going to give us our mean or our average, which kind of makes sense here, right? Because the average is going to be the split between these two spikes, right, at about 33. So that's kind of what we're doing here in terms of visualizing for a t-test. But for the actual output, when you do this, the t-test between a therm AOC and therm Democrat, you're going to take these and you're going to place all this information in an Excel sheet if you want to do a t-test. And again, that comes in the supplemental lecture to this, right? That's not in R. You don't have to use a t-test, though. You can do something like ANOVA. ANOVA is 3 or more groups in 1 interval ratio. Again, you can use a box plot for this. And so instead of using Democrat, sorry, excuse me, I need to sneeze. I thought I needed to sneeze. Instead of using Democrat, we're going to use Dem ideology, and Dem ideology has 7 different categories. Let's go to the right and show you. Dem ideology has 7 different variables that go along with it, 7 being the most conservative and 1 being the most liberal. So we would say probably we think that people who are more ideologically conservative are going to be more favorable towards Trump or have higher feeling thermometer scores. What does the box plot say? Just about that same thing. That those who are 5 to 7, right? So those people that are somewhat closer to conservative, somewhat conservative, or very conservative have much higher feeling thermometer scores, right? 60, 80, and 85, as measured by that thick black line, which is the mean, as compared to those who are either more moderate or liberal with very low feeling thermometer scores towards Trump. And so we're able to have some general kind of understanding that there's a difference between ideological groups and their feelings towards Trump. And then again, we'd have that one-way ANOVA test where we're able to see that there are significant differences as shown by our p-value and our F statistic. Similar to the t-test, you could take these and put these into a Google Doc table or an Excel table in R and make it a little bit prettier. So we also have chi-squared, which we're going to use the SJPlot stuff that we've talked about. It's comparing multiple categorical variables. And so I'll give you both a visualization tool and the table making tool. We know that the table making tool from our chi-squared lecture was the sjt.xtab function. And it takes our 2 different variables and it creates the frequency tables for them. Yep, over here on the right-hand side, and it gives us on the bottom the x squared, which is chi-squared statistic, and the p-value. So the p-value being 0 shows us that there is definitely a systematic difference between different partisan groups and how much they favor free tuition at public universities. And so again, like this is a perfectly fine table to put into your final paper. But say we wanted to visualize some of these categorical variables. Well, in the last case, we had interval ratio, right? We had those variables that started with therm. So they were the feeling thermometer scores that went from 0 to 100. Well, in this case, is free college is from 1 to 7 ordinal, right? And then our other is a categorical variable for party ID. And so in order to get categorical visualizations, we should probably be making bar plots. And so we're going to use this ggplot code to create bar plots for Dem party ID in this case. And so I'll show you what that looks like. Dem party ID, as a reminder, looks like 1, 2, 3. And so we have to tell R instead to not treat it like a number, but treat it as a factor. And so that's what's happening here, is it's just making a new variable called party categories. That is a factor version of that. So you have to run line 72. You have to run line 72 in order to get line 75 going. So then we have party categories. We want to get a ggplot that is a bar plot where the x-axis is free college, and our fill is the different parties. So let's show you what that looks like. Okay. So is free college is a 7-point categorical ordinal level of support or opposing, right? So 1 is oppose a great deal and 7 is favor a great deal. So we see that for those who oppose a great deal, the vast majority of those people are Republicans, because remember, Republicans are 3. So 3 over here on the right-hand side and 7 over here on, or 1 over here on the left-hand side. So oppose a great deal and Republicans. Most of those people are centered here because Republicans are against things like free public tuition, right? It's more about individualism and paying your own way and things like that. The opposite is also true in terms of Democrats. So our number 1 category, this kind of peach group, they're most prevalent in this favor a great deal, or the 7 category. But we also have quite a few independents, or category 2, in this particular case. And this kind of all comports with our frequency table here on the right-hand side. So this all kind of makes a lot of sense in terms of both our findings from the chi-squared and what's happening in the chart. Because we have an NA category from the party ID variable, it's showing up as an option. NA just means not available or not applicable. There's ways to suppress NAs, but it takes a little additional code. And so I'm leaving it off for now, but for the future, you can look into how to omit NA variables as we move forward, but that's a little bit beyond the scope of this class. So I'm going to give you one other example of this sort of chi-squared option, right? So comparing multiple categoricals. So say we wanted to compare something like party ID by gender. So we want to see if there's a systematic difference between men and women in the different parties. So maybe, are there more women in the Democratic Party? Are there more men in the Republican Party? We do see that there is definitely a significant chi-squared association here, but we want to have a bit better understanding through the descriptives as well. So we're going to do the same thing that we did with Dem party ID and make it a factor variable here on line 84. So we'll run that, right? You can either double click and command return or click it. And then we'll run our ggplot code. So again, you can double click or you can just put your cursor there and run it. And we see that we do generally see that there are more Democratic women, right, than there are in other groups, but it's not by a huge margin. And it seems to be pretty 50-50 for men and independents and Republican groups. So there might be something going on here, but we're not super sure. As it also shown by the smaller chi-squared result, right? It's only 15, so it just means it's a bit smaller, so it's not as extreme. We also see that there are NAs here. We'll just ignore those for now, but just know that you can omit those in using some additional code later on. So we've got, let's see, we did chi-squared, we did ANOVA, we did t-test. Let's start to move to correlation. So correlation is a bit more difficult. So remember we had for SJPLAT, we had this tab-core table. So let's run it. The tab-core table is going to give you something on the right that looks like this, where it takes all these different variables and gets correlations for them. So let's interpret this first one, for example. So the correlation between the therm AOC, or how warmly you feel towards AOC, and the demographic age is a negative 0.206, which means as age increases, warm feelings towards AOC decreases, right? So older people are not as warm towards AOC. And let's do let's say this 4.1. So Dem ideology, how liberal conservative you describe yourself, and then the feeling thermometer towards AOC, that's a negative 0.498. So that means as someone gets more conservative, they're less in favor of AOC, which makes sense because she's a Democratic or liberal representative of the House. And so more ideologically conservative people are negatively related to her AOC score. So we had something like this, but we can also kind of visualize this in terms of a correlation matrix. And so there's some kind of a little bit more advanced code for this. So essentially what you can do here is you can pick out certain sets of variables and do correlation matrices for them. This is the simplest version you can get with the data set that we have. If you want to do something other than, so the EM ones, I'll show you what the EM variables are. So let's go to view DF. So our EM variables, anything that starts with EM is how afraid, angry, happy do you feel? So all these different emotions. So we can look at the different correlations for the different emotions. And we'll select those out from our paper data set 3, anything that starts with EM, and we're going to create that into a new data set called new. And we're going to run this sjplot function again called sjp.core, and then in parentheses new. And it's going to give us this correlation plot where the more blue a value is, the higher the correlation is, and the more red it is, the lower and more negative it is. So let's interpret this one. So it's bottom left-hand corner, 0.642. How happy do you feel versus how hopeful do you feel? So if you expand this, if you click this right here, if I click into this, it's not going to show you it in the Zoom recording, but if you click this, it'll make it bigger so you can actually interpret and read what's happening down here. How happy do you feel and how hopeful do you feel? So hope and happiness are highly correlated because they have a positive correlation of 0.642. Hope, though, is negatively correlated with being irritated. So, right, that's this first column right here on the left. Hope is negatively correlated with being irritated. 1, 2, 3, 4. So the fourth row up on the left at negative 0.219. So the more hopeful you are, the less irritated you are, which makes sense, right? So there's a negative correlation between these negative and positive like emotional valences, and there's positive correlations between positive and positive. So it makes a lot of sense, right? So a good example too would be like the outrage is correlated with other negative variables. So if they're the same kind of emotional valence, so hope and happiness go together, but something like outrage and irritation also go together because they're both negative. So you can create something like this with correlations as well. But this is perfectly fine. This one right here, the table for your output for the correlation stuff. Again, because we're looking at different kinds of interval ratio or categorical variables, your visualization, if you can't get this correlation tab thing to work, you can also just do histograms and bar plots of any of these, right? According to whether or not it's an interval ratio or continuous. Okay, so our last one is regression. So again, we have a regression code, and then I'll show you how to make different visualizations with it. So we're going to make a regression called reg AOC using the linear regression function. Our dependent variable is therm AOC. Our independent variable is Democrat. Our other independent variable is Democrat education. This is a multivariate regression with 2 different independent variables. And our data set is paper data _3. So we're going to run that, and we're going to run the summary. And so we see that both being a Democrat and being more educated are highly correlated with being more warm towards AOC. We're only explaining about 17% of the total variation here. While it is statistically significant, all of these things we're not totally explaining what's happening with Therm AOC. And so we know that there's more room for improvement there, but this is totally fine for us to do now. So we'll start with tab model. Again, this comes from SJPlot with our reg AOC, what we created, this new regression. And you'll get something that looks like this on the right, which has an adjusted and regular R squared. Remember, we interpret the adjusted, and then the different estimates and p-values and confidence intervals for those things. So this is an example of something you could screenshot and put in your final paper. We also have this new function that we kind of talked about a little bit in regression called plot model. Plot model takes your regression object and also allows you to add a title and also allows you to show p-values. You're going to get all of this information and specify certain colors. When you run this plot model, you get something that looks like this. So this is, again, a dot and whisker plot. The dot represents the beta estimate. So the dot here is at 26.84, same thing as in our table over here. And then the whiskers go from 24.63 on the left to 29.06 on the right. So it gives us the full range and a significance value, which we love. It does the same thing for DEM education. So this is a visualization of our different beta values. We're also able to see that this estimate is significantly different from 0, which is our null, right? And so when this dot and whisker thing doesn't cover 0, we have statistically significant results. When this whisker is over 0 here on the left, then we wouldn't have statistical significance. So this is a perfectly fine thing to put in your final paper. We also know we can use scatter plots for regression. So that's here on the bottom in line 143. We'll run this really fast in ggplot. So this is looking at our independent variable. Our dependent variable of interest is Therm AOC. That's our Y. Our independent variable is X. It's STEM education. And then we're going to use the geom point to draw like a version of a scatter plot. DEM education is technically categorical, and so it's not perfectly scattered, but what we do see is this line right here, which actually just functionally captures what's happening here on the left mathematically. So it gets our estimate at 13.57. That's where this, in theory, if it keeps going down, it'll hit the y-axis, and then gives us a predicted value. So when somebody's a Democrat, where they're going to fall on this line, and when somebody is more educated, where they're going to fall. And so we get that through both adding the geom point function and the geom smooth function. So the geom smooth function allows us to say we want to put a linear regression line on here. So that's all the different visualization tactics you can use moving forward for your final paper. The final paper, I'm going to reduce the total amount of pages you need to write. I want you guys just to focus on having a good looking table, a good looking visualization of some sort. It can either just be the variable or be the relationship you're looking at. And then you'll have a little bit of this to do for your final exam. But again, this portion of your homework is extra credit because I just want to incentivize you guys to do it, and also give you an opportunity to make up some missed points from your first few assignments. So any questions, definitely hit me up on Discord. Also, if you liked this lecture style better, please let me know.